Well, we have a question here, question 6. The question says that given f of x equal to a quarter x squared, and then x is lesser than or equal to 0. 6.1, the question says determine the equation of f minus 1 in the form f minus 1 of x equal to. All right, I'm gonna write, excuse me, the question over here, we have like question 6.1. F of x is given by a quarter x squared, and then x is lesser than or equal to 0. And then what else? we need to find f minus 1 of x. All right, now what are we going to do in this situation? Now I am going to write over here y. I want to write over here that y equal to a quarter x squared, okay? And then to find the inverse is when we reverse the variable, okay? We change the variables, we swap the variables, so we call y x and then xy. Now this will be x equal to a quarter y squared, okay? And then we're gonna make y subject of the formula. Now, if I move the quarter on the other side, this will be 4x equal to y squared. Now we can square root both sides, okay? We square root over here, we square root over there. Then this will become 2. We square root because we need to find y. So this become plus minus actually 2 square root of x. Okay, let me write equal to y like that. Now so this is the value of y. I'm going to say therefore f minus 1 of x equal to plus minus square root of actually plus minus square root of plus minus 2 square root of x. So this is f minus 1. Okay, then question 6.2 over here. So we did 6.1. Now we're going to do 6.2. The question says, excuse me, on the same system of axes, sketch the graphs of f and f minus 1 indicate clearly the intercept with the axis as well as at other points on the graph of each of f and f minus 1. Now I'm gonna move my board a little bit this side. Do 6.2. Okay, let's sketch the graph. So now see, I'm gonna draw my graph here. Yeah, that's the x-axis, I mean the x axis, and then I want to do the y-axis. Let's see the y-axis something there. All right, now we're going to, okay, this function is given by 1/4 x squared, and then we have a restriction here because it is said that x is lesser than or equal to 0. We know this is a parabola, okay? Normally it's a parabola. The graph should be something like this. Parabola goes like, okay, I'm trying to draw a parabola. This parabola would be something like that, okay? But the fact that we have a restriction, okay? This part, as I said, this part is a restriction. So we will not, we will only want the values of x that are lesser than or equal to 0. So now the more than or equal to 0 would not be part of the graph. So our graph has only one arm, the left arm. Now, we draw the graph of this. This is the graph of f, the graph of f of x, and then if I can take one point, I want to take a random point on this graph. Okay, because we have like f of x equal to over here, f of x equal to 1 over 4 x squared. I'm gonna just write over here a point plotting technique. Okay, say give and also we know that this point is at the origin. This graph lies at the origin of this point here. Let me show it over here, because zero is there. And then if I want to show another point, I want to use that thing. Say, okay, let's say x has a value of if x is the value of not 0, I can take a value of if I say 4, no, I can take a value like, yeah, let's say if x is equal to 4, for instance, we have 4 over here. 4 squared will be 16, and 16 divided by 4 will be 4. Okay, so this might be y also will be 4. Then we have a point 4, 4 there. There's a point that's a point 4, 4. No, this is on the other arm. Let's actually check the point -4. Yes, if I start with negative, if the point was -4, so we have -4 to the power of 2 will be 16. 16 over 4 is 4, so it's the point -4, 4. That's the point. Now, this is the graph of f. Now, the graph of f minus 1, we know that this graph must be symmetric to the line y equal to x, and the line y equal to x is this line. It's the line that's on the right. I want to draw. It's actually the line that makes 45 degrees. Okay, that's the line y equal x. So it must be symmetric to this line. Now, so this line must be symmetric to the other line. So this other line must come over, must be somewhere there. I'm gonna draw it like this, something like that. This is the graph of f minus 1. And then if I want to take a point, if I take a point like 4, for instance, yes, I prefer to take a point like 4. Over here, I can just take my point plotting technique. If x has the value of 4, for instance, normally my graph was supposed to be like this. My graph was supposed to be like this, but we said here this other we have the function is not full. Okay, we only take like only the negative part, so the inverse also we can only consider the negative part, so we cannot take this other arm. Reason why we need to edit here is normally f minus 1 of x makes plus minus 2, but because we only consider the negative part, we will not take the positive, so this answer should be then negative 2x. Yes. Now, and then the positive arm also of the inverse function will be taken away. So we're only left with this other arm, the negative arm. So f minus 1. If I take a value like x is equal to 4, and then y would be, if I sub 4 there for x over here for x, y will be -4, because square root of 4 will be 2 times -2 makes -4. So you have another point here. Point 4 and -4. So this is the inverse. Okay, and then the next question, the other question, question 6.3. 6.3 says, is f minus 1 a function? Give a reason of your answer. Well, when I look at this graph, yes, I will say f minus 1 is a function because this will pass the vertical line test. Okay, I'm going to draw a vertical line test here. this is how we can check that whether a graph a graph is a function or not. So because this is a vertical line, if the vertical line can cross this function at exactly one point, then we say it is a function. If it crosses at more than one places, then it's not a function. Okay, wherever I can draw this vertical line, the vertical line can only pass through f-1 at exactly one point. Wherever I can draw it, can only cross at 1 and 1 point. So f-1 is also a function. Thank you.